March 7, 2026, 2:14 a.m. local time, the Persian Gulf. Two Ticonderoga-class cruisers sit 47 nautical miles apart in the dark waters south of Bandar Abbas. The USS Philippine Sea and USS Gettysburg. Combined displacement, over 19,000 tons. Combined crew, nearly 750 sailors. Combined Tomahawk loadout, classified. But tonight, 47 of those missiles have already been assigned targets. Every single one of them is aimed at the same place. Khorramabad, a name most Americans will never hear. A facility buried so deep inside the Zagros Mountains that the men who built it believed no weapon on Earth could reach it. Tonight, the United States Navy is going to test that belief. I'm your host at Navy Axis, where we break down the most critical naval operations shaping global power. And this story isn't about whether American missiles can hit their targets. They can. They always do. This story is about what happens when 47 perfectly aimed Tomahawk cruise missiles strike a facility designed from the ground up to survive exactly that kind of attack. When every warhead detonates precisely where it was supposed to. When the blast craters are exactly where the targeting officers predicted. And the enemy keeps operating anyway. Because 72 hours after the most concentrated cruise missile strike on Iranian soil since the Gulf Wars, seismic sensors picked up vibrations from inside that mountain. Engine tests, ballistic missile engine tests. Khorramabad survived, and that changed everything. To understand why those 47 Tomahawks failed to kill what they hit, you need to understand what's inside that mountain. And to understand that, you need to go back. Iran's underground missile program didn't start with Khorramabad. It started with fear. April 14, 2024. Operation True Promise. Iran launched over 300 projectiles at Israel. Drones, cruise missiles, ballistic missiles. The vast majority were intercepted. The strike was a strategic humiliation. Tehran learned two lessons that night. First, their offensive missile capability needed to survive a preemptive strike. Second, anything on the surface was a target. The Islamic Revolutionary Guard Corps Aerospace Force had already been tunneling for years. The Imam Ali missile base near the Iraqi border, facilities near Tabriz, storage complexes in the Alborz range. But those were first-generation hardened sites. Tunnel entrances wide enough to spot on Google Earth. Ventilation systems visible from commercial satellites. Depths of 20 to 40 meters, enough to survive a conventional airstrike. Not enough to survive a dedicated penetration campaign. Khorramabad was different. Construction began in 2019, accelerated after the Soleimani assassination. Iranian engineers studied every American bunker-busting strike of the previous 2 decades. The 2017 Shayrat airbase attack, where 59 Tomahawks cratered runways that were operational again within 24 hours. The 2003 attempts to kill Saddam Hussein in underground bunkers near Baghdad. The Israeli strikes on Hezbollah tunnels in southern Lebanon. They reached a simple conclusion. Depth defeats everything except the heaviest penetrators. And the heaviest penetrators require the heaviest bombers, flying directly over defended airspace. So they went deep, 80 meters beneath solid Zagros granite. Not limestone, not sandstone, granite. One of the hardest natural rock formations on the planet, with a compressive strength exceeding 200 megapascals. The facility itself spans an estimated 14,000 square meters of operational space, multiple chambers connected by reinforced tunnels, independent power generation, diesel generators with fuel reserves for 90 days, filtered ventilation systems with blast valves rated to overpressures of 50 pounds per square inch, water recycling, communications hardened against electromagnetic pulse, and inside those chambers, EMAD and Gajr medium-range ballistic missiles, liquid-fueled, range 1,700 to 2,000 kilometers, capable of reaching any U.S. military installation in the Middle East, capable of reaching Tel Aviv in under 12 minutes. This was Iran's insurance policy, not a deterrent you could see on parade, a deterrent you couldn't destroy. Back to the Persian Gulf, March 7th, 2:14 a.m. Aboard the USS Philippine Sea, Captain David Harmon stands in the Combat Information Center. The CIC is bathed in the blue glow of tactical displays. The room is quiet except for the hum of electronics and the low murmur of watchstanders confirming final targeting coordinates. The strike order came down from 5th Fleet Headquarters in Bahrain 6 hours ago. CENTCOM authorization. National Command Authority approval. Every Tomahawk in tonight's package has been individually programmed with GPS coordinates, terrain contour matching data, and digital scene matching area correlator terminal guidance profiles. Each missile knows exactly where it's going. Each missile knows exactly what it's supposed to hit. The target set is comprehensive. 8 missiles assigned to the primary tunnel entrance on the facility's western face. 6 aimed at the secondary entrance, a vehicle with portal on the northern slope. 12 allocated to the ventilation shaft complex on the ridgeline above the facility. 9 targeted at the communications array and surface support buildings. 7 assigned to the access road network, specifically the switchback sections carved into the mountainside. 5 tasked with the electrical substation that feeds surface-level infrastructure. 47 Tomahawk Block 5 cruise missiles. Total payload, approximately 47,000 pounds of high explosive. Estimated cost, roughly $90 million. All stations, this is the TAO. Confirm weapons release checklist complete. The tactical action officer's voice is flat. Professional. This is process. Weapons, TAO. Checklist complete. All birds show green. TAO, aye. Standing by for launch authorization. Captain Harmon picks up the red handset. 47 miles southeast, aboard the Gettysburg, Captain Maria Santos holds an identical phone. Philippine Sea confirms weapons free. Execute Bravo 7 on my mark. Gettysburg confirms weapons free. Ready on your mark. 3, 2, 1, mark. The forward VLS cells erupt. Each Tomahawk leaves its canister on a pillar of flame, the solid rocket booster hurling the missile skyward before the turbofan engine ignites and the weapon drops to its cruise altitude. The sound is a rolling thunder that shakes the hull. Sailors on deck feel the heat wash across their faces even behind blast shields. From the Philippine Sea, 28 missiles in 94 seconds. From the Gettysburg, 19 missiles in 61 seconds. 47 Tomahawks now racing northwest at 550 miles per hour, skimming the wave tops of the Persian Gulf before climbing over the Iranian coastline and threading through pre-planned corridors in the Zagros range. Flight time to target, approximately 74 minutes. If you're watching this and want to see how this strike plays out, hit that subscribe button now, because what happens next at Khorramabad is something Pentagon planners are still debating today. The Tomahawks navigate autonomously. Terrain contour matching guides them through mountain valleys, hugging ridge lines, following riverbeds. Iranian air defense radars, a mix of Chinese-supplied HQ-9 batteries and domestically produced Bavar 373 systems, detect some of the inbound missiles. But cruise missiles flying at low altitude through mountainous terrain are extraordinarily difficult to engage. The radar returns blend with ground clutter. The engagement windows are measured in seconds. 3 Tomahawks are intercepted, 1 by a Bavar 373 battery near Desful, 2 by short-range Tor M1 systems deployed around Khorramabad's perimeter. That's a 6.4% interception rate. 44 missiles continue to their targets. 2:29 a.m. The first impacts. The western tunnel entrance takes 8 direct hits in a span of 11 seconds. Each Tomahawk Block 5 carries a 1,000-pound DBROCT penetrating warhead, the digital bomb rack-compatible tandem variant designed to defeat hardened structures. The warheads are optimized for penetration into concrete and rock before detonation. The first missile strikes the steel blast door at the tunnel mouth. The door, 6 inches of hardened steel backed by reinforced concrete, buckles inward. The second missile enters the gap. The third and fourth widen the breach. By the 5th impact, the tunnel entrance has collapsed under thousands of tons of fractured granite. The northern entrance receives similar treatment. 6 missiles. Total destruction of the portal structure. Rubble fills the tunnel for an estimated 30 meters inward. Above the facility, 12 Tomahawks rain down on the ventilation complex. These shafts are the facility's lungs. 1.5-meter diameter steel-lined channels drilled vertically through the mountain to bring fresh air to the chambers below. The missiles obliterate the surface infrastructure. Blast valves, filtration units, exhaust manifolds, all reduced to twisted metal and shattered concrete. The communications array vanishes. The electrical substation is cratered. The access roads, those carefully engineered switchbacks that allow missile transport vehicles to reach the tunnel entrances, are carved apart by 7 precision impacts that leave gaps too wide to bridge. On the surface, Khorramabad is destroyed. Every satellite pass over the next 48 hours confirms total surface devastation. Thermal imaging shows fires still burning in the rubble of support buildings. Synthetic aperture radar reveals the depth of cratering at the tunnel entrances. The National Geospatial Intelligence Agency rates the facility as functionally denied in its initial battle damage assessment. CENTCOM receives the report. The Pentagon briefs the National Security Council. Mission accomplished. Khorramabad is offline. And then, 72 hours later, the seismographs light up. The monitoring stations belong to the Comprehensive Nuclear Test Ban Treaty Organization, a global network of seismic, hydroacoustic, and infrasound sensors designed to detect underground nuclear explosions. 2 stations in Turkmenistan and 1 in Oman register a series of low-frequency vibrations originating from the Zagros Mountains. Location: within 2 kilometers of the Khorramabad facility. The signature is distinctive. Not an earthquake, not a mining blast. The frequency pattern matches solid fuel rocket motor ignition tests, the kind conducted when verifying missile propulsion systems before deployment. The intelligence community's assessment lands on the president's desk within hours. Khorramabad is still operational. The missiles inside the mountain survived. The facility's crew survived. And someone down there is testing engines, as if 47 Tomahawk cruise missiles never arrived. The question that dominated every briefing room in Washington for the next week was simple: how? The answer was physics, and it was devastating in its simplicity. A Tomahawk Block 5 warhead weighs approximately 1,000 pounds. Its penetration capability against rock depends on impact velocity, angle, and the hardness of the target material. Against reinforced concrete, the DBROCT warhead can penetrate roughly 2 meters before detonation. Against granite, dense, crystalline, with almost no fracture planes, penetration drops to less than 1 meter. Khorramabad's operational chambers sit 80 meters below the surface, 80 meters of solid granite. That's not a barrier, that's a geological shield. To put it in perspective, the energy required to penetrate 80 meters of granite exceeds the kinetic and explosive yield of every Tomahawk ever manufactured combined. The missiles were never going to reach the chambers. They were designed to destroy surface infrastructure, collapse entrances, deny access, and they did exactly that. But the facility was designed to operate in isolation. Those 90-day diesel reserves, the water recycling systems, the filtered air circulation that could sustain hundreds of personnel even with surface ventilation destroyed, the internal communications that didn't rely on external antennas. Iran's engineers hadn't just built a bunker. They'd built an underground fortress designed to absorb a cruise missile attack and keep functioning. The blast doors that the Tomahawks destroyed were meant to be destroyed. They were sacrificial barriers, designed to collapse and seal the tunnel rather than allow blast overpressure to channel into the mountain. The rubble filling the entrances didn't trap the personnel inside, it protected them. Secondary exits, concealed tunnel openings kilometers away from the main facility, camouflaged and unreported in any intelligence assessment, allowed personnel and even equipment to move in and out. This was the nightmare scenario that U.S. Strategic Command had wargamed for years. A hardened underground facility that could absorb a conventional strike and continue operations. The technical term is ride-out capability. Khorramabad had it. The National Security Council convened in the Situation Room on March 10th. The agenda had one item: what now? The options were stark. Option 1, the GBU-57 Massive Ordnance Penetrator, 30,000 pounds, 20 feet long, designed specifically to defeat deeply buried targets, carried exclusively by the B-2 Spirit stealth bomber. The MOP was built for facilities like Khorramabad. Its penetration capability in hard rock exceeds 60 meters. A tandem strike, 2 MOPs impacting the same point in sequence, could theoretically reach 80 meters. But delivering MOPs to Khorramabad meant flying B-2 bombers over Iranian airspace. The B-2 is the most expensive aircraft ever built. $2.1 billion per airframe, with only 19 in the active fleet. Iran's integrated air defense network, while degraded by the cruise missile campaign, still included mobile S-300 PMU, 2 batteries, and indigenous radar systems. The probability of a B-2 surviving the mission was high, perhaps 95%, but a 5% chance of losing a B-2 over Iran was strategically unacceptable. The technology compromise alone would set American stealth programs back a decade. There was also the escalation calculus. Cruise missile strikes were one level of warfare. Stealth bomber penetration raids were another. The signal sent by B-2S over Tehran would transform a limited naval campaign into something that resembled the opening hours of a full-scale war. Option 2. Sustained siege. Cut off the facility from everything it needed. Destroy the electrical grid feeding the surrounding province. Crater every road within 50 kilometers. Maintain continuous drone surveillance and strike any vehicle attempting to approach. Effectively starve Khorramabad of fuel, food, and personnel over weeks or months. This option was operationally feasible but strategically slow. It required sustained air operations over Iranian territory. It meant destroying civilian infrastructure, power plants, roads, bridges that served Iranian citizens with no connection to the missile program. The humanitarian implications were significant, the diplomatic fallout potentially catastrophic, and it assumed the secondary exits were known and could be monitored. Intelligence assessments admitted they couldn't guarantee they'd identified all the concealed access points. The Zagros Mountains stretch over 1,500 kilometers. The tunnel network could emerge anywhere. Option 3. Accept the reality. Khorramabad survived. The missiles inside it survived. Adjust the strategic calculus accordingly. This option was the hardest to accept politically. The president had authorized $90 million in cruise missiles. The Navy had executed a flawless strike, and the target was still shooting back, metaphorically and potentially literally. But option 3 had advocates in the intelligence community who argued that Khorramabad, while surviving, was significantly degraded. Its surface infrastructure was destroyed. Its primary entrances were sealed. Its communications were disrupted. Even if the facility could operate for 90 days on internal reserves, it couldn't sustain operations indefinitely. And a facility that couldn't launch missiles, because the launch infrastructure on the surface was destroyed, was a facility that could store missiles but not use them. The debate consumed 4 days of NSC meetings. Declassified summaries of those sessions, later obtained through congressional oversight, reveal a fundamental disagreement between the Pentagon and the intelligence community. CENTCOM wanted option 1, send the B-2S, finish the job, accept the risk. The CIA argued for option 3, containment, monitoring, patience. The president sided with neither. The decision, according to sources familiar with the deliberations, was a modified version of option 2. Sustained interdiction of the facility's supply lines. Continuous ISR coverage. Preparation, but not execution, of a B-2 strike package that could be authorized within 12 hours if intelligence indicated an imminent missile launch from the facility. The Navy's role shifted from strike to surveillance. P-8. A Poseidon maritime patrol aircraft began flying daily orbits over the Zagros Range, their synthetic aperture radars mapping every road, every trail, every goat path within 100 kilometers of Khorramabad. MQ-9 Reaper drones maintained 24-hour coverage of the known and suspected tunnel exits, and the analysts went to work on the hardest question of all: how many more facilities like Khorramabad existed? The answer was unsettling. Iran had been building underground military infrastructure for over 2 decades. The Islamic Revolutionary Guard Corps controlled an estimated 3,700 kilometers of military tunnels, a number that may sound improbable until you consider that North Korea, with a smaller economy and less advanced engineering, operates an estimated 8,000 kilometers of military tunnels. Not all of these were hardened to Khorramabad's standard. Most were shallow cut-and-cover facilities, effective against conventional bombing but vulnerable to penetrating munitions. but at least 4 sites in the Zagros Range showed geological and construction signatures consistent with deep granite burial. 4 potential Khorramabad's, 4 facilities that could absorb a cruise missile strike and keep operating. This was the strategic reality that the Tomahawk strike revealed. Not that American missiles were inaccurate, not that the Navy had failed. Every missile hit its target. Every warhead performed as designed. The failure was conceptual. The United States had spent decades perfecting precision strike, the ability to put a weapon exactly where it needed to go. But precision is meaningless if the weapon can't reach the target. The physics problem was not new. Military planners had understood the limits of conventional penetration since the 1991 Gulf War, when coalition strikes failed to destroy Iraqi hardened aircraft shelters buried under just a few meters of reinforced concrete. The GBU-28 bunker buster was developed in response, literally designed and built in 27 days to address that specific shortcoming. The GBU-57 MOP was the next evolution. Bigger, heavier, designed for deeper targets. But the MOP requires a delivery platform that can reach the target, and against a country with modern integrated air defenses, that delivery platform is exclusively the B-2 Spirit. 20 aircraft, responsible for the entire global deep strike mission, irreplaceable. This is the dilemma that Khorramabad crystallized. The United States can hit anything on the surface of the Earth with cruise missiles launched from ships hundreds of miles away, no pilot risk, no airspace penetration required, but anything buried deep enough is immune to those weapons, and reaching deep targets requires putting the most valuable aircraft in the inventory over hostile territory. Iran understood this equation better than anyone assumed. Their tunnel engineers had done the math. 80 meters of granite meant that only a B-2 with MOPs could threaten the facility, and a B-2 mission required a political decision that no president would make lightly. By going deep enough, Iran had effectively transferred the decision from a military commander to the commander-in-chief. That was the real defense, not the rock, the calculation. Like this video if you think this changes the way you see underground warfare, because the next part of this story reveals what the Navy found when they started looking closer at those mountains. The intelligence community's deep dive into Iran's tunneling infrastructure produced results that were briefed to the Senate Armed Services Committee on March 18, 2026. The classified briefing lasted 4 hours. The unclassified summary, released 2 days later, contained a single sentence that captured the strategic implications. Current U.S. conventional strike capabilities are insufficient to defeat the most hardened category of Iranian underground facilities. That sentence represented a tectonic shift. For decades, American military doctrine had rested on the assumption that any target, anywhere, could be destroyed with sufficient precision and firepower. Khorramabad disproved that assumption. The Navy responded with immediate operational adaptations. Strike planning for future operations against hardened facilities shifted from destruction to denial. If you can't reach the chambers, you can deny the facility's ability to sustain itself. That meant targeting not just the visible infrastructure, but the invisible supply chains. The fuel trucks that traveled mountain roads at night, the electrical cables buried along highway rights-of-way, the water pumping stations that filled underground reservoirs. This approach required a different kind of intelligence, not satellite imagery of surface installations, but human intelligence about supply schedules, construction crews, maintenance patterns. CIA operations in Iran, already expanded under the current administration, were redirected toward the tunnel program. Sources within the IRGC construction jihad, the engineering arm responsible for underground facilities, became the highest priority recruitment targets in the region. Meanwhile, the Tomahawk program itself came under scrutiny. The Block 5 variant used at Khorramabad was the most advanced cruise missile in the inventory, equipped with a maritime moving target capability and a joint multi-effects warhead system. But its penetration capability had been designed for a different era of threats: surface bunkers, aircraft shelters, command posts built under a few meters of concrete. The Defense Advanced Research Projects Agency had already been working on next-generation penetration concepts. Project Obelisk, a classified program to develop a hypersonic kinetic penetrator that would use sheer velocity, Mach 8 or higher, to drive a hardened warhead deep into rock without explosive energy. The physics were promising. At hypersonic speed, the kinetic energy of a 500-pound tungsten penetrator exceeds the explosive energy of a 2,000-pound conventional bomb. But Project Obelisk was at least 5 years from operational deployment. 5 years, during which Iran's tunneling would continue, during which new facilities would be completed, during which the problem would get harder, not easier. Back aboard the USS Philippine Sea, Captain Harmon received new orders on March 12th. The ship was reassigned from strike operations to what the Navy called persistent maritime interdiction, patrol the Gulf, monitor shipping, interdict any vessel suspected of carrying supplies to the IRGC tunnel program. It was a different mission, less dramatic than launching Tomahawks into the night, but in many ways more important, because the lesson of Khorramabad was that the most sophisticated cruise missiles in the world couldn't solve a problem that had been engineered specifically to defeat them. The sailors aboard Philippine Sea didn't know all of this. Most of them believed the strike had been a success. They'd launched 28 Tomahawks, hit every target, and watched the satellite imagery of a destroyed facility. The classified seismic data, the engine tests 72 hours later, wasn't briefed below the captain's level. But in Washington, the implications were clear. Iran had found the gap in American military power, not in speed, not in accuracy, not in the willingness to strike. The gap was in depth, literal, geological depth, 80 meters of granite, the width of a football field, turned on its side, made of stone. And until the United States developed a weapon that could reach through that stone without risking a B-2, Iran's underground arsenal would remain intact, waiting, fueled, ready. Khorramabad didn't change the balance of power overnight. The United States Navy still controlled the Persian Gulf. American air superiority remained unchallenged. The carrier strike groups patrolling the region could devastate Iranian surface forces in hours. But deep beneath the Zagros Mountains, in chambers that no Tomahawk could reach, Iran's ballistic missiles sat in their launchers. Maintained by crews who had ridden out the most powerful cruise missile strike their facility would ever face. The missiles survived. The mountain held, and every strategic planner in the Pentagon knew it. Comment deep strike if you think the U.S. should have sent the B-2S. Comment contain if you think the siege approach was the right call, because this debate isn't over. It's just beginning, and the answer will shape American military strategy for the next decade. The outcome at Khorramabad wasn't a failure of American power. It was a revelation of its limits. 47 Tomahawk cruise missiles, each one a marvel of precision engineering, each one striking within meters of its programmed coordinates. Total surface destruction, 0 American casualties. A textbook strike by any conventional measure, and the target survived. That's not a story about Iranian strength. It's a story about physics, about the difference between hitting a target and destroying it, about the oldest lesson in warfare, that the defender always has the advantage when they're willing to go deep enough, dig long enough, and build strong enough. The United States will adapt. It always does. New weapons, new strategies, new ways to reach what was once unreachable. But on March 7th, 2026, at 2:14 in the morning, 47 Tomahawks flew into the Zagros Mountains and proved that precision isn't everything. Sometimes the mountain wins.